All right, we're back. We're on page 46, and what we are going to do is we're going to take the information that we just figured out about how to use a guide function and turn it into the graph of the reciprocal to graph a cosecant function. So what's going to happen, and it takes a little while to get used to this, it's really all about the guide function. So you're going to spend almost all your time creating the guide function. Then once you have that, it's just boom, 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 graph is done, right? So some people will get to the point where they're just kind of intuitively just plotting the information for the guide function instead of graphing the guide function. But if you do graph the guide function, so if you graph the guide function, make sure it is dotted, not solid, because it's not a part of the graph. So additionally, vertical asymptotes, not a part of the graph. They need to be dotted. They should not be solid. And then finally, the thing to remember is really that you're never going to cross the original graph, but you will intersect it at the relative extrema. So it will intersect at the relative extrema. And then like with that in mind, let's just do it. So we have all this stuff. So the guide function that we're going to use, and you don't really need to do this, you literally just turn the cosecant into a sine. So it's still going to be -3. Cosecant becomes sine. 5 pi over 2 x plus 4 pi. So that's going to be pleasant. Plus 4. This is your guide, right? So you literally just turn cosecant into sine. You don't do anything else. Now we're going to graph or figure out how to graph the guide function. So the period of the guide function is 2 pi divided by 5 pi over 2. So 2 pi divided by 5 pi over 2 is 4/5, right? Because that was 2 pi divided by 5 pi over 2, which is 4 pi over 5 pi. So 4/5. The increment is 1/4 of that, so it's 1/5. So this is why we spend so much time trying to get good at sine and cosine, because if you can graph sine and cosine, you can graph basically pretty much any other function, actually, any other trig function, but specifically cosecant and secant. So it's like your invested time there is worth double what you might have thought it would be worth. Start, we have to take 5 pi over 2 times x plus pi over 4 equals 0. So I'm actually just going to subtract it right away, minus 4 pi. We multiply by 2 and divide by 5. So I get x is -8/5. Conveniently, already have a common denominator between the start and the increment. If it didn't, I would rewrite it. Sinusoidal axis of the guide function. So a cosecant function actually doesn't technically have a sinusoidal axis because, or maybe, well, it doesn't have an amplitude, that's for sure. I think you could probably make an argument one way or another that it has or doesn't have a sinus. It's not really a sinusoid, so how would it have a sinusoidal axis? But for the guide, it's 4, and you're going to see that that's just as important for cosecant as it is for the corresponding sine graph. The maximum of the guide, which we'll see will sort of become a relative minimum for the cosecant graph, is going to be, we're at 4 and we can go up 3. So it's going to go up to y equals 7. We're at 4, we can go down 3, so we go to 1. Asymptotes, domain range, just wait on those, right? So we need to go 1 to 7. So 1 to 7. I think I should probably start here with 1. 3, 4, 5, 6, 7. Okay, I'm definitely going to pick that up and move it. So what I can do is, let's do this. It's nice to have a little bit above and a little bit below your maximum and minimum for the guide when you're doing cosecant and secant because of how the graph is going to work, right? So the guide function will fit between 1 and 7. The actual function we want is completely above 7 and completely below 1. So you want a little bit of space so you can at least see what's happening there. So for our guide function, sinusoidal axis is at 4. So let's just dot that in. So I'm not gonna do my usual put in a line and then trace it. I'll just go for it. And you can see this is going, ooh, not a great one. Here, let me scroll. There we go. Okay, so the starting point is at -8/5. So I can actually fit 0 in here, which is good. So I will put in the x-axis. And then -8/5. So I'm going to put it like here, I guess. And I would like to somehow note that that's, my starting point. So maybe I'll just highlight it. So -8/5. Now I'm going to go 2 boxes per increment. Increment is 1/5. So we'll go to -7/5, -6/5, -5/5. So I'm not going to get to 0, which is totally fine. But if you're one of those people who's obsessed with getting the y-axis on your graph, you're going to have a bad time on this one. So that's pretty much why I don't really care about that. -10/5 obviously reduces, but why bother? 11/5. And it's like, do you need to label all of these? Probably not, but I think that it's a classy move. And like, why not do the nice thing for the person who's trying to read your graph? All right, so focus on the guide, right? So it's a sine function, it's negative, it's gonna go intercept, minimum intercept, maximum intercept. So the guide function will have an intercept at x equals -8/5. So what I'm gonna do, because I'm thinking way ahead here, I'm gonna make that an open circle. Now, anytime I hit the sinusoidal axis, I'm gonna do an open circle. Anywhere it's a max or min for the guide function, closed circle. So we're gonna go, where are we? So here, then open circle, then here, then open circle. So I'm doing the open circles because anywhere we intersect the sinusoidal axis is actually gonna become a vertical asymptote. So I already know what's gonna happen there. And so I'm like planning ahead, basically. Here, 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 and there. All right. So our guide function, if we choose to dot it in, so let me use like, this is, I think, the least extreme color that I have available. My guide function would be like this. So you don't really need it, but if you need it, you need it. I mean, just, go for it, but make sure it's dotted and not solid, because it's not really a part of the graph. It's just giving us a really good guide, which is why we call it a guide function, what the graph should look like. Oh my God, this is taking forever. So I probably won't be dotting this in again because, man. And there, okay. That's our guide. Now remember, what we want to do is take that, turn it into the graph of cosecant. So anywhere we hit the sinusoidal axis, the sine function before we shifted it up would have been undefined, would have been 0 rather. So that's before the shift, we would have gotten 0. The reciprocal of 0 would be undefined, and that's why our vertical asymptotes move up and down with the sinusoidal axis of the guide function. It's order of operations, basically. So we dot these in. I should have done the copy and paste thing again, just now remembering that that was an option. So got our sinusoidal, nope, our vertical asymptotes. Okay, and again, why do they go with the sinusoidal axis? It's order of operations. Sine would have been 0 before we shifted up and down. We try to take the reciprocal of 0, we get undefined, then we shift up. So we're shifting up undefined. We're just taking the vertical asymptotes and shifting those up. So that's what's happening there. And then the maximums and minimums also shifted, but before you shifted them, you would have created your cosecant graph, which is why when we actually do our graph, we can now just fill in our shape as this. Because the order of operations would have had us creating our cosecant graph first and then shifting. So all of the shifts that happen to the guide function happen to the cosecant. We get this. So the process really is, can you graph the guide function? And you should be able to if you've been keeping up. Even though this is not the easiest. It's kind of an annoying process, I guess I would say. Depends on how good you are at sine and cosine, really. All right, so if you remember when we did sine and cosine graphs, we were like, what are the intercepts we see? Can we generalize those? The reason we were doing that was because the intercepts that we saw in sine and cosine are the asymptotes of our cosecant and our secant graphs. That's why we've been doing that every time. So here, I'm gonna say that I see a vertical asymptote at, let's say at -8/5. I see another one at -6/5. And so if I write those down, -8/5, -6/5. Okay, so how far apart are they? Well, they're 2/5 apart. So I'm going to say the asymptotes that I see are x is -8/5 plus 2/5 n. N is an, oh, nope, why do you auto-fix that all the time? N, now I can't even write. Here we go. And usually the solution when I'm having trouble writing on this is to make it bigger. N is an element of the integer. So that's equal to, because those are the asymptotes. Now the question of the domain is everything except the asymptotes. So we just kind of half answered that. So I'm going to say x is an element of the reals. X is not equal to -8/5 plus 2/5 n, where n is an element of the integer. So it's annoying to answer those questions consecutively. Now the range is sort of interesting, because if you know the range of the guide function, the range of the reciprocal function is kind of like the complement of that, except you do include the max and min. So here, the range, I can go anything from 7 up, that's where that graph lives, or from 1 down. So I'm going to say that my range is, that's supposed to be a y. Y is less than or equal to 1. That's not supposed to be negative. To 1, comma, y is greater than or equal to 7. So that's how I prefer to write my ranges. You know, if you like interval notation or whatever, like, go for it. You know, I'm not going to judge you for that, but I like to write them with the inequalities. Let's just answer these. So what feature will the graph of the reciprocal function have at the points where the guide function intersects its sinusoidal axis? It'll have a, vertical asymptote. Also, so for calculus reasons, justifying things in calculus, try to avoid the word it. So I will say the reciprocal. The reciprocal will have, and then because I can move that, the reciprocal will have a vertical asymptote. And then if the guide function had a vertical asymptote, what feature would the reciprocal have at that x coordinate? So the recip will have a 0, because the vertical asymptote comes from trying to divide by 0. Therefore, reciprocal has 0 in the numerator. I should probably write out numerator, because it's not really obvious what num would stand for in that particular context. But there you go. So we created the guide function and just turned it into cosecant. That's what we're going to do for secant, any cosecant, any secant graph. We are going to just create the guide function and turn it into the graph. So knowing sine and cosine is the key thing. So if you don't know those, go back and get good at those, because there's just no point in trying to do these if you're not already really good at sine and cosine. So hopefully I will see you in the next video, where we're just going to keep doing things. So see you there.